Let's calculate the universal gas law constant using a lighter. We're going to collect butane gas by water displacement. So we're going to go ahead and take a graduated cylinder, completely fill it full of water. Right now there's an air bubble that's trapped. Sometimes this happens due to surface tension and some other things that allow water droplets to basically form little pockets of gas on the graduated cylinder. So go ahead and make sure you've gotten all of that gas out. If you don't get all the gas out, then just realize this is going to be one of your sources of error. The next thing is we're going to have a lighter that is damp already. Part of this keeps our students from going ahead and trying to strike it and getting it to catch fire. The other is, and this is a source of error, we're going to assume that the amount of water that clings to the lighter at the beginning and then at the end is going to be roughly the same. Now, this is known to be a source of error. This is kind of a sloppy lab, but it gets the point across for students that we can at least get close to the universal gas law constant. So I'm going to go ahead and measure that. Realize that I've got two thermometers going on right now. One is measuring the water temperature in Fahrenheit. The other is mentioning the room temperature in Fahrenheit. It would be best if we'd use everything in Celsius, but right now I've got it set at Fahrenheit. All right, let's go ahead and bubble about 90 milliliters of gas into the graduated cylinder. As the gas goes in, it will push water out. And a modified lighter will allow this to go much, much faster. Now, when you modify your lighter, you'll basically use the little plus minus switch that's on there. And if you pop off the little metal safety bracket, that little switch is actually a small plastic wrench. You can drag it to the plus side, lift it off, drag it back to the negative side, let it set down, drag it across again, and you can do that a few times, allowing it to have a tremendously large flame. Now, we don't want to have a tremendously large flame, but we would like to let out more butane. If you do this too much, you'll have an uncontrolled bleed of the butane, and so we want to know exactly how much butane is still left in the lighter. We don't want it just constantly bleeding out, because we want to account for the amount of butane that we actually used, not what's going into the air that we can't capture. Now, once we've gotten about 90 milliliters, we're going to go ahead and back off. Make sure no gas bubbles that are trapped inside of the lighter chamber are still there that could maybe slide off to the side, pop out, and not get captured by the graduated cylinder. And then we're going to go ahead and dry it off the same way that we did at the beginning. So we want to do that in the same manner. We can then go ahead and take it to the scale and get the new mass. Now, the assumption is that the water clinging to it now is equal to the amount of water that was clinging to it at the beginning. That's not necessarily true. This is very much a source of error that we have to account for. But if we assume that, then when we go to our scale, whatever missing mass there is must have been butane. So we'll go ahead and get that. And while we're doing this, we're waiting about 5 minutes to see what happens in the graduated cylinder. Now, notice those two temperature differences. The volume of the gas might actually change over 5 minutes. We're really hoping that the water level inside and outside of the graduated cylinder are equal. If they're not equal, then that could be a problem with our pressure. It could indicate that we still have a lower pressure on the inside, or perhaps a higher pressure on the inside than on the outside. And that can cause some issues with some of our calculations. Again, this is a rather sloppy lab, just trying to get the idea of the ideal gas law constant being able to be solved by students. We're hoping that we're close, but we also want to realize what could have gone wrong that gave us a number that isn't what all of the scientists tell us that it is. So after waiting about 5 minutes, we'll go ahead and record the volume then. So we've got our temperature of the water, temperature of the air, the mass loss that should be butane, so that'll give us our number of moles. We have the volume now, and we can go to a weather app to check on the pressure. Now, it was pretty boring to collect data, so let's go ahead and ignite the butane that we collected. A little fireball makes this all much more satisfying. Hopefully you enjoyed the lab. Make sure you take care of your lab write-up.